Welcome back here to the Air Crash Investigator, and today I'm going to have a look at a very sad case, in fact more than one case, to show that when the pilot actually loses the ability to control his air vehicle, well, tragic results must follow. Before we carry on, just a quick reminder that SEAMS, or the Smart Electronic Aviation Management System, on that you'll be able to do your dangerous goods, CRM specific aircraft or helicopter, and everything online. We are looking here at two aircraft, a Bell 222 and a Porter. And the first thing that I need to say is that I know that both these investigations has not been concluded. So because it's not concluded, I'm certainly not here to make any suggestions, but it will be short on my side if we don't have a look at probabilities and possibilities and not coupling it exactly to say this is really what happened. And you can see that I'm covering for my side, but I still need that we get to learn something. I say catastrophic failure. In some cases, the pilot tried to do something, but you know what? When you've got failures like this, and specifically the two that I am just referring to at this moment, the pilot had no say in the matter at all afterwards. Just to show you that you've got your Bell 222, and that was the end of that one. Here we had the police Pilatus Porter, and you can see that was just after takeoff here. The accident history, and I must make it clear that the history that I'm giving here is not the agreed legal history. I just need to give us something to say, all right, what is happening, so that we can make a safety case, so that we can learn. So remember, it's not to point fingers, it's to learn. First of all, mechanical catastrophic failure. In both these cases, that was undoubtedly the case. Then I say that control linkages, wing struts, attachments, stuff like that, well, I cannot say, but it seems to that these sort of parts did play a role. Now, the jury is not out on this one 100%. But I need you to see that there are some very critical points on your air vehicle. And, well, we must make sure that we understand where they are and what it actually means. So I'm not saying that this was a wake-up call. It was just a very, very sad call. Critical components crack testing did not point out the impending failures. This is not something new, and many a time parts may be in such a position that you cannot do crack testing with the best equipment such as x-rays, but you will use some or various kinds of fluids that you will either paint on or spray onto the part, and if there's a hairline crack, it will actually show a discoloration there. When the crack is undetectable through this method, which is possible because it could be out of sight. So, this is like a catch-22. You can't use the correct method, but, so all parties involved in the cases, I'm sure that they thought the components were fine and correct, and they signed it off. So such structural failures takes away control from the pilot immediately. All right, there is absolutely nothing that they can do. It's like an in-flight breakup, and we know of many such cases. But some of the cases that we are known of is where the pilot inputs would, for instance, start mast bumping, or when very high G loads put in, some parts of the aircraft would either not be able to take it and you get flutter and all that kind of stuff. But in this case, we are talking very, very specifically about linkages, control rods, we're talking about brackets and. So let's carry on. So these accidents are by nature, well, quite obviously they are fatal. Now, on the right-hand side, I've just got, when we talk about brackets and so on and attachments points. But what went wrong? First, I'm not going to dig in the beginning to say, in this case, just follow the argument because we've got to get to the technical side of things. But I've got to start with the human. And I say, there's normally a crew member involved, most of the cases. And the common mistakes is willfully, when it comes to your standing operated procedures, and this is where we see that there is an attitude problem. Oh, you can't tell me. I know. I can do this. I can do that. And if there's not enough oversight, then, it slips in that the exception to the rule will also all of a sudden become the rule. And the truth rule will become the exception. Then we're in big trouble. And then I say, well, it could have been mistakenness. There could be a little bit of sloppiness, too fast working. Distractions. Man, the one thing that we must remember when people work on aircraft or you're busy flying, distractions are the one thing that we're not built to be able to pay enough attention to all the different parts. It's not in it. And if you believe you've got that capability, I think you're in trouble. All right. Poor training, poor oversight or no oversight. And, this thing is where no ramifications to keep anybody in check. In other words, we moved into this era where, human rights override. What about the human rights of the people that were at the receiving end? Fair amount of triggers are mechanical, and these could be poor maintenance, bogus parts. We'll get back to that one. Saving money knowingly. This one to me is quite interesting, knowingly. Overfly maintenance markers or maintenance schedules and. And that's an old trick. We know that it's used extensively where people just don't want the Hobbs meters or the tachometers to give the correct indication of what was happening so that they can get a little bit more money out of what they are doing. Not a very good human factor. I would say in this case it wasn't even close. Okay. Using crack detection methods not capable of exposing the hairline cracks, cost-saving methods. Sometimes it's just too expensive to get to the X-ray environment. So you could use other methods, which is not as good, and especially when it goes to real critical parts. I say here, hidden mechanical due to improper procedures prescribed, or the AME or the mechanical engineer who's signing out will say, in my experience, that's not a problem. So, don't worry about that. If somebody tells me not to worry about something, worry. Then, most crucial, and here we need to actually just pay a little bit of an inspection of flight controls, linkages, and cables. Attachment of linkages to services needed for flight control. Now, wait. There is a huge difference between a flight control to manage the helicopter blades, such as something in the 222, where there's a few ton of pressure running through it. Then it comes to a light aircraft and you're just taking off. But at the end of the day, remember, if there is a failure of those components, well, eventually, if we don't look after something, it will break. It's guaranteed to break. Load-bearing brackets for wing attachments, engine attachments. And we look at a few things, man. The wings come off, the engine come off. We had this case where the engine came off. And actually all that happened is that when they attached the engine onto the body, instead of using the right steel for aviation, they used DIY, they put it in there, they torqued it up, but as the pressure came, they became compressed, and that meant there was a looseness. And when there's a looseness, there is going to be catastrophic failure. In this case, we don't think that was had any bearing on it, but remember, I want us to get our minds a little bit open. Like in helicopters, you would get a flex plate failure, then the engine won't be there, and maybe if it's the wrong one or the right one, it could either take your engine out, or it probably could take out, let's see, the tail rotor, in which case you've got problems. And then the last one I say, we forget that weight and balance is such a problem. Remember, if weight and balance is not within the required limits, you're going to run out of controls, and then you cannot control. Then you lose control. Preventative measures. The first one, obviously, follow the manufacturer's guidelines, especially when special instructions are published. There are normally well-documented reasons, but only useful if you are aware of the special instructions. Wow. That which you do not know, you cannot know. If you don't know that, you don't know. So, because we don't know what is there, we go to very specific sites, we have a look at it, and we must make sure that we pick up everything that we do not know and then get to know it. That is just basics 101. All right. Mechanical personnel must be made aware of stresses and load-bearing surfaces attachment during their safety awareness. I'm just saying here, you mustn't do the safety stuff just because you have to do it, man. You've got to do it because you're professional. The point is, I know I'm slightly on thin ice here, but what are you doing with your safety meetings? What are you doing with your yearly meetings? Is it just a forced place to get together? Well, the results are bad. We really have to train, teach, make aware, and continually be at it. Then tracking of control linkages where load is crucial, or for that matter, any part. Let me say, just from a pilot's perspective, the moment that you put a critical part in, and let's say you get it from the spares bin or wherever it is, that part must have a serviceable label on it. But if you get to certain linkages, that once they are attached in place, there's no way you're going to get to it to x-ray it unless you take the whole thing apart. And that's why sometimes other methods are used to try and detect cracks. It's purely from a seriously practical point of view. My point is, if you pick up that part and you've got a serviceable label, the part must be traceable, but you must also see the proof of what tests this specific section went through to be declared serviceable. Then I say assembled parts may be difficult to even or impossible to x-ray, but any part used in the critical control areas must be cleared through the enhanced processes detected before. So I'm just digressing on the same one as we're talking about. And now I specifically want to talk to the pilots. And there's a few things I want to say, and please take this personally. First of all, I say, remember, if you do a pre-flight, it will not necessarily or naturally expose everything. But there's a second part here. I say, if you don't do a proper pre-flight, then you are more damned if you don't. I say, you cannot just be another jockey to interface with your air vehicle, but you must have a much wider understanding. Let's just couple this to this one where I say, better your technical knowledge, the better your decision making. Is that anything, or has it got anything to do with the two accidents we're looking at? No, not necessarily. Remember, it's things that come up to say to pilots, hey, sometimes we miss stuff because we actually do not do. We look, but we do not see. We listen, but we do not hear. And then the last one, I'm going to talk now to the Class 2 test pilots and the acceptancy pilots. Not worried about the Class 1. They follow different procedures. But here's a couple of things I really need to stress. And the first thing is going to be after a mandatory periodic inspection and maybe after a major overhaul, as I put it there, when it comes to the end of its lifetime, it's required by law for you to confirm whatever had to be done was done. Whoa, I'm just saying to you, when you're an acceptance pilot or you are a test grade 2 and you're now going to accept this, whatever was done to the aircraft, you have to make sure, even after a normal MPI, that everything was done that had to be done. That includes all the bulletins. Test pilot, you must look for evidence of oversight where controlling agencies and services are concerned. These are major areas. If somebody's countersigned that work was done, did that person sit in his or her office and just sign it? Oh, did you do? Yeah, you did. Okay, well, fine, I signed it out. Not good enough. Dual inspection means that the second person must actually physically look, see if everything is either wire locked or split pinned or, did the nylock fit in the right way and whatever the case may be. Were the parts fitted correctly? Did you do the mass and balance correctly on control surfaces? Did you do this? Very important parts. Okay, so this cannot be just administrative exercise. Definitely not. Many a time the test acceptance pilot can detect a slippage. Now, I'm not saying that it's dishonest mistakes or honest mistakes. I'm saying that, remember, you're the last in the quality check, in the quality chain of checks. And if you don't take that job serious to the right level, you shouldn't be there. Go and see what the law requires you to do. And then I say, acceptance pilots must be aware of all ADs. We can talk about airworthiness. Maybe there's other directives. Maybe there's special bulletins or instructions or whatever the case might be. You will not know about these unless you follow the correct procedure to find out if there were any that had to be paid attention to. And then you must make sure that it was. So, not an easy one. Here I'm not trying, or I did not try, to point any fingers. I've raised very uncomfortable questions, and I pointed out that our test pilots, our acceptancy pilots, I'm talking about Class 2 test pilots here, your job when you accept an aircraft is the most important part of the whole picture. Until the next one.